Hello boys and girls, and welcome to lesson 3-1, fractions and decimals. Today I'm going to have a helper help me make this video. I have Matthew right here, and what we're going to do is we'll take turns solving some of the questions that we have in the examples, and solving as we go along. Matthew will take turns as well. Okay, so let's get started. Okay, so what will we learn? We will write fractions as terminating or repeating decimals. Terminating means the decimal part is a 0, so it ends right there, it terminates. Or repeating decimal is often what we refer to as a bar notation. Comparing fractions and decimals. So here we're going to look at decimals and fractions and see which one's greater than, less than, or equal to. Okay? So as we were saying, here's a couple of terms I would like you to get familiar with: repeating decimal and terminating decimal. Right? Some fractions like half and 3/4 can be written as a decimal by making equivalent fractions with denominators of 10, 100, or 1000. You see, we can make these denominators simply make them up to 100, and when we do that, to make this 100, we multiply this by 50, so we multiply this by 50, so it's 50 over 100. Over here, we multiply this by 25, and this by 25, so it's 75 over 100. That's one way to do it, and also that will give you your percent. However, any fraction can be AB, where B does not equal 0, can be written as a decimal by dividing the numerator by the denominator. So when you divide the top by the bottom, you will have your decimal. So AB equals A divided by B. The decimal form of a rational number is called a repeating decimal. If the repeating digit is 0, then the decimal is a terminating decimal.
Okay, for number 1A and 1B, we have write each fraction as a decimal. So we're going to go with 4/5. So we have to divide 4 divided by 5. So 0. Minus 4, 0.
So our answer is 0.8. Thank you, Matthew. But you can also see, boys and girls, that that's one way to solve it. We can simply divide the top by the bottom, but many of you understand that this could also be written as an equivalent fraction. You can write 4/5, and whatever you do to the 100, to the 5 to turn into 100, you do the same to the 4. So you multiply the 5 into 20, let's multiply the 4 to 20. Okay, and that'll give us 80. Now it's 80, when you say this fraction, you say 80 hundredths, so that you know that the 80 is in the 100th place, so you write it 80 hundredths. But as many of you know, when you have a 0 as a decimal, this is a terminating 0. You do not have to write it. You can simply write 0.8. Right? So those are two different ways to get your answer. Matthew did it correctly here, and this is a different way to do it. But since we're learning how to divide the numerator by the denominator, this is the better way to do it for now. Okay, Matthew, please now divide 3 divided by 16 to convert this into a decimal.
Okay, so now let's start up by writing 3 divided by 16. So for our first one, 0. And how many? 16, 7, 30, 1. 14. And 0. Then how many are there? 8.
16 times 8 will give you what?
128.
128. Good job. When you subtract, you will have
12.
12. Good job.
20. If it's 1 less, it's 7. And then we subtract.
So it would be
1, 12.
And then you have 8.
I get 8. And then 0.
5.
And then 5.
And there you have it. Okay? Thank you, Matthew. That was well done. Now, what we have here, Matthew solved and he went not just to the 10th, 100,000, he went all the way to the 10,000s. And the reason he wants to go into a 10,000 is because if you ever want to write this decimal as a percent, you know you have to multiply by 100. So it would give you, if you need it as a percent, it would give you 18.75%, which is right to the 100th in the percentile, okay, in the percent version. So this would be the furthest I would want you to go. Now go ahead and write your answer down, 0.1875. Okay, now for the next example on page 95, we're looking at repeating decimal. Okay, when we write a fraction as a decimal, use bar, what we say a bar notation, for repeating decimals. Over here, you can see that when you divide any number divided by 12, you're going to get a repeating decimal at the thousandth place. It starts to repeat by sixes. When you divide by 11, okay, your repeating decimal, it repeats, the first two numbers start to repeat, 18, 18, 18, and that will continue on. So you need to put the bar over both numbers, okay, as you can see that they've shown you right there. So why don't we go ahead and try this. A trick that I do want you to remember, and I've always remembered this since I was little, is that any number over 9, when you convert it to a decimal, so any number divided by 9 is going to be this number, bar notation. So right away, you should memorize that this is going to be 0.7 bar notation. If I had 2 9ths, it would also be 0.2 bar notation. So any number that is, any numerator that is over the 9 will be the numerator bar notation. Always remember that little trick. It'll help speed things up. Okay, let's try negative 5 over 6. Now remember, boys and girls, this negative can be assigned to either numerator or denominator. You're always going to have a positive divided by a negative or a negative divided by a positive. Regardless, the decimal will be negative. Okay? So 5 divided by 6 will be a bar notation. You see, I have 6 divided into 5. There's none, but so I make it a 50. 6 into 8 is 48, and when I subtract, I have 2. I turn that into a 20. 6 times 3 is 18, and I'm always going to have 2 left over. So now I make that a 20, and 6 into 3 again will be 18, as you see in the bottom, and I'm always going to have 2 left over, which will be turned into 20, and I can only multiply by 3. So 3 is going to be my repeating decimal. I don't need to write this last one. You see that? So that one right there is not necessary. So it's 0.83, and my 3 is going to be a repeating 3, my bar notation. Something I brought up in class many times and I've repeated is that you need to remember a few things. Just the same way you memorize your ABCs, memorize some landmarks in fractions, realizing that half is always decimal 5, 2/3 is decimal 6, bar notation, 1/3, and so on. This is a nice, easy way to work with proportions, comparing fractions, and converting fractions to decimals and percent. If you could have this as a nice basis. So the key word here is memorize these terms. Now we're going to compare. There's a couple ways to compare. Now you can turn both of these expressions into a decimal, or you can turn them both into a fraction, whichever one you think is best. Or if you turn them into a fraction, you have to find the common denominator so that you can see which one is greater. For this one, I would simply turn it both into a decimal, because I know how to count by eighths. I know how to count by 8 over 8 is 100%. But every 1/8 is 12.5. So here I'm missing 1 out of 8. So what I'm going to do is just subtract 12.5 from 100. And that's going to give me 87.5. So this, as a decimal, will be written as 0.875. Okay, oh, sorry, I did that again. That's a percent decimal. What I meant to write was 0.875. And you can see that this number over here, we don't write it, but that's a 0 there. So this is 5 thousandths greater than this one. So your answer should be that. Okay, let's have Matthew try this one for us.
Okay, for this one, I have the option of making it a decimal or just looking for the common denominator. So I'll look for the common denominator.
Okay, so you're going to look for the common denominator of 15 and 12, and whatever you do to the bottom, you must do to the top.
So I find a common denominator, and it's 60.
So it looks like you multiplied 15 times 4 to get 60, and you multiplied 12 times 5 to get 60, if I'm not mistaken. Whatever you do to the bottom, remember to do to the top.
Okay, so now when we divide the top over here when we multiply the top over here times 4, it's 28. And we multiply this top by 5, it's 25. But we're talking about negatives, so which one is actually bigger and which one is actually less? So 25 over 60 negatives is actually bigger because we're talking about negatives. Remember that the bigger the number, when it's a negative, the less it is in value.
Thank you for that, Matthew. Now let's take a look at this word problem. I believe we have to compare like we've been doing so far. Let's read it. Over the weekend, 16 out of 28 of the 8th graders, girls, the 8th grade girls, and 19 out of 30 of the 8th grade boys went to see a new comedy movie. Did a greater fraction of girls or boys see the movie? What I'm going to do is I'm going to keep them as fractions, but I'm going to take the 16 over 28 and I'm going to simplify. If I divide them both by 4, I get 4 over 7. And now I'm going to work with the 4 over 7 and compare it with the 19 over 30. Now I know I can't simplify this one because 19 is a prime number. Now what do I have to do to find a common denominator between these two? The lowest common denominator that I can find for these two numbers is actually quite high. It's 200, 210, and 210. Well, the 30 was multiplied by 7. And so I must multiply the 19 by 7. When I multiply the 19 times 7, I get 133. Now what I did was actually I multiplied 20. I rounded this up to 20 and multiplied it times 7. I got 140, and then I just simply subtracted one of the 7s because it's 19 sevens, not 20 sevens. And I got 133. So now I have here 4 times 30. 4 times 30 is 120. And there we go. Now it's easy to compare. Okay? Which one's greater? The boys. So more boys went to the movie. So therefore, a greater fraction of boys went to the movies. And that's all for today, boys and girls. Leave the guided practice for class and the independent practice for class. All you have to do is just the video. See you in class.
See ya.
I'd like to give a special thank you to Matthew for helping us today. Thank you, Matthew.
See ya.